Hello, my name is Alan Ivan, student ID M008514040, and this is a presentation video for the second assessment at robot manipulation module. For this particular assessment, we were required to design a robot manipulator to satisfy the requirement of collecting recyclable material from a conveyor belt and placing it into three different bins of different heights, which are placed near the conveyor belt. These represent the storage facilities for plastic, metals, and glass, the recyclable materials that are supposed to be collected from the conveyor belt. Several assumptions have been made for this project. The suction cup is estimated to a 200 millimeters height, as well as the recyclable material height, 200 millimeters. Several manipulators have been studied, and it's been revealed that a manipulator with a decreased number of joints and links, it's cheaper. However, it has influence in speed, in a sense that it's quite limited because the rotation degrees resulting from the reduced number, it's increasing the execution time. On the other hand, when we got a manipulator with multiple joints and links, the whole rotation gets divided between those, and they travel a shorter distance in terms of rotation, and this is increasing the speed. However, for this particular assessment, the focus was on minimizing resources and try to create a manipulator with a minimum number of joints, links, and a minimum link length. The connection was made such that we avoid z-axis offset. This makes it easy to calculate for the inverse kinematics, where is the case. In order to find the minimum required reach distance, several triangles have been formed and the hypotenuse were calculated in order to, for example, in this image, calculate what would be the minimum distance except the shoulder arm and the wrist arm. For the link 2 and 3, what would be the minimum length in order for the robots to be able to drop a recyclable material up to the highest bin. This is a calculation with a 2D view from top. There is another triangle because apparently from the input image, the bins are not perfectly aligned with the robot, and there is another triangle which would increase the total distance. However, because we need 1.5 meters across the conveyor belt, this becomes the new length for the link 2 and 3. Least but not last, we need to consider DL approach, DL move when we need to make when we approach the recyclable material on the conveyor belt. This increases the total length of link 2 and 3 to 1,540 millimeters. That would mean 757 millimeters per link with respect to link 2 and 3. After the lengths of the links and the number of the joints have been established, a robot diagram have been created representing all the manipulator joints and the links between them, as well as the theta angles and the coordinate systems according to their orientation, including a coordinate system for the end efflector. After the robot diagram have been created, the DH table has been created, plotting the lengths of the links, the angles of the joints, and the offsets, the potential offsets, and also the theta angles. The code at the beginning illustrates the declaration of the links and joins, the configuration of the robot, which also includes a limit and movement. This was done with the intention of protecting from unwanted movements, like around the longer path or just odd movements. The setup creates a robot and establishes the incipient quaternions and also the animation time. These are the targets on the 3D space. The first one is the near space, the near place on the conveyor belt, the furthest place on the conveyor belt, the plastic bin, the metal bin, and the glass bin. This is the main loop where independence of which of the function is running, they can run one at a time. It will run the inverse kinematics by providing the translation of the target start point, and also the inverse kinematic consisting of the translation of the destination point. Ongoing in the function, this will return a set of coordinates that is then plotted with a J trajectory in a loop. So back, forward, and backwards. This is done while true, so it's done infinitely. These are the functions for each of the journeys from the near side on the conveyor belt to all the 3 bins, and from the furthest side, from the far side of the conveyor belt to all the 3 bins. We can give it a go now. Oh, that's quite unfortunate. Unable to perform the assignment because the value of the title is not convertible to Java. That is a surprise because the code has been tested. I think this might be something to do with the MATLAB. Let's test a simple code to see if this is the case. Okay, let's test one single link. See if it works. Let's clear first. Test. Oh, yeah. It seems that MATLAB won't let us run the code for some reason, because this is obviously a clean line of code that won't run. It's so unfortunate we cannot provide a graphical representation of the robot. Hopefully, as the code will be submitted in a zip file, the assessor will be will test the code. That was all for this assessment. Thank you very much for listening. Bye now.